everyone. My name is Mackenzie.
I'm Vanessa.
And my name is Katie.
And welcome to the Couch Potato Lab, the show where we bring the science to you.
My name is Vanessa. My pronouns are she and her, and my fun fact today is that I have a scar in my belly button.
Very cool. So, as I said before, my name is Mackenzie. I'll be your host for today. My pronouns are she, her, and a fun fact about me is that I am so excited to be back at the Couch Potato Lab that I laid in bed thinking about it for probably 100 hours last night because I was so excited.
100 hours, Mackenzie.
100 hours, that's
wow.
a long time.
I definitely thought there was only like 24 hours in a day.
I don't know. I don't know what happened.
You care so much for the Couch Potato Lab.
I do. I'm just so excited to be back. It feels great.
Awesome. So my name is Katie. My pronouns are she, her. And my fun fact for today is that I hate onions. I cannot stand the taste of onions. However, I do like onion rings. And I don't just take out the onions from the breading. I actually eat the entire onion ring. But I don't know. Onions just don't cut it for me.
Sounds like you really like just deep fried foods. I think that that's it, Katie.
I think that's a fair assumption, Mackenzie. So before we get started with the show, we just wanted to take a moment to recognize that this live stream and eyes is operating on Treaty 4 land, which is the traditional territory of the Nayawak, Nakaway, Dakota, Nakota, and Lakota peoples, as well as the traditional homeland of the Métis-Michif Nation. We also recognize that we have a diverse audience and that you may be watching this live stream from other numbered treaties or from unceded land. So thank you for taking this time to recognize this with us.
Great, thank you. So we were so busy getting ready for the live show today that I actually didn't have time for my coffee break. So if you don't mind, I'm just going to go ahead and eat my donut and drink my coffee.
Oh, that's looking pretty good. What do you think, Vanessa?
It's pretty good. I like the sprinkles, making me also want to treat, but I had time for my coffee break.
Yeah, fair.
It is so good. It's filling my tummy right up.
Well, Mackenzie, do you
So
actually
good.
know what happens like when you eat a donut and like when you eat food?
No, I just eat it. I think that's it.
And you've never questioned like really what happens once you actually chew the food?
Well, like I guess I have. I don't know all the details, but I think it has something to do with digestion.
Yeah, exactly. I was thinking for today's show that we could dive in a little bit more with digestion. What do you guys think?
I
Yeah,
like the sounds of that.
I think that's a great idea. Maybe I'll take a pause on my coffee break again and we'll look at some digestion. How does that sound?
Actually, that's a great lead-in. So I first wanted to do a fast, quick overview of what digestion is. So if we want to look at the screen, let's find out exactly what is a part of our digestive system. We should have a picture popping up. Perfect. So we can see in that colored picture that there are multiple sections of our digestive system, that it's not just composed of our mouth and our stomach.
Yeah, it looks kind of complicated. I think that we might need to go through it step by step so that I can understand it a little bit better.
Okay, I think I have an idea of how we can do that. If we
Okay.
want to focus back here on me, perfect. So today I brought my super duper cool Frisbee, and it's actually shaped like a circle. So it's perfect that Mackenzie was eating this donut. So let's imagine that this Frisbee is Mackenzie's donut. So first, what's going to happen is she's going to put the donut in her mouth and she's going to chew it up. It's going to get nice little chunks, and then it's going to travel through the pharynx to a place called the epiglottis, which is a little flap that food will go down one of two tubes. So I think once it reaches the epiglottis, it should go down the trachea. Oh,
I think something went wrong here.
just kidding. That's the wrong tube. Food should not go down the trachea. That's actually part of the respiratory system, and that's where we breathe. If food goes down that tube, that is not going to go right for us. So it must be the other tube. So that flap, the food should lead to the esophagus.
I think that worked
Perfect.
better.
We made it to the esophagus. That's the long tube. It does this nice wiggle all the way down into the stomach.
All right, so now we're in the stomach. And now a lot of people think that a lot of the digestion happens in the stomach, but that's not really true. The stomach acts more like a chamber, and then from the stomach, it heads to the small intestine where a lot of the digestion takes place. So I'm going to send it there.
All right, so now we are in the small intestine, and like Mackenzie said, this is where a lot of the digestion takes place. So a lot of the nutrients from the food are taken up into the small intestine so that the body can use it as energy. But there's still like a lot of stuff that's in this food that the body doesn't really want, including a whole bunch of water. So I'm going to send it off to the large intestine.
Perfect. The large intestine is right where we're going to take all the water out that our body is going to hold on to, and then the last place that it goes.
It goes to the colon. And from here, well, the rest is history. And, well, oh, whoopsie.
Well, Mackenzie, I think you're right. And do you understand it a little bit better now?
Like, I kind of understand it. I understand that there's a lot of different parts and that they all work together in a system, but I think that we still need to go through it a little bit slower. Do you think we can go step by step?
Yeah, let's do it.
All right. Where should we start? I think we started in the mouth. So, Katie, do you think we can start in the mouth?
We definitely can. Let's start at the mouth. We are going to take this nice and slow, just like our actual digestive system. So when you eat food, it actually takes about 6 to 8 hours for your body to totally digest that food. It's not a very instantaneous process. But once again, we're going to start in the mouth. And I actually have a cool little demo to show everybody what mechanical digestion is. So there's two types of digestion. There's mechanical and chemical. And so I wanted to show what the mouth does, which is mechanical digestion. So when we're chewing food, we're really mixing it up in our mouth. We're getting it into smaller pieces because I don't know about you guys, but it would not work well if I was to swallow that donut whole. I don't think that would work very well for my body.
Yeah,
So
I don't think that would feel very nice.
exactly. So let's take a look at what mechanical digestion could look like. So I have this blender here, and I put some frozen berries in this blender. So just like our teeth, the blender works to kind of chew up the food in our mouth. So I'm going to go ahead and start this, and we're going to see what happens to the berries.
It seems like it's kind of breaking it up, but like only at the bottom. It seems like it's like a little bit too solid, that it's not a solution.
Yeah, exactly. I don't know what's happening because with mechanical digestion, it should work.
Yeah, so you said that there was two types of digestion, digestion, right? That's what we're talking about. Mechanical and chemical. So I think that we need to combine chemical digestion with mechanical digestion, and maybe it'll work a little bit better. So I think we need to introduce something called saliva. So saliva is kind of like water. It's the liquid that our mouth produces. But this saliva doesn't just contain water. It actually contains enzymes, electrolytes, and mucus. And all of these things work together to start the chemical digestion, and that starts right in our mouth. So something really cool about saliva is we produce between 1 to 2 liters a day. So that's like almost, depending on what type of milk jug you have, but that's like the milk jug that's like this big a day, all in our mouth. So what this does is it helps to keep things moist and like lubricate it to help us when we mix it up. And it helps to break things down in our mouth as well.
Wow, you know what? Just talking about saliva, I actually saw Vanessa salivating when you were eating your donut, Mackenzie.
Yes, my mouth was
Whoa.
watering a lot as soon as I saw it, especially the sprinkles. So yeah, my mouth is kind of wet now.
Yes.
You know what's another cool fact about saliva is that it's not just in this type of science, but I don't know if you guys have ever heard of Pavlov, was a famous psychologist that did a lot with dogs and salivating. So what Pavlov would do is he would ring a bell, and then he would introduce food and the dog would start salivating once the dog would see the food. And eventually what would happen is when he would ring the bell but not give the dog any food, the dog would still salivate. And that's called classical conditioning. So we even kind of see that too. So even if I smell food, sometimes I'll start salivating. So it's very interesting.
Yeah. So it's kind of like our body is preparing for the digestion that it's about to take place when we're eating.
Okay, so if we're going to add some chemical digestion into our blender here, I think I'll add some water, and let's see if that is going to make this a little bit easier here.
Yeah. While she's getting that ready, I actually have another cool fact about dogs. So sometimes, like after a dog goes for a run or something like that, sometimes you'll see the dogs, they get really hot and they start panting and they're all like running around. They're like, right? They're running around. That's actually because our salivatory glands, they're not just good for producing saliva. They do a lot of other things. And one of them is they have temperature regulators in there. So because dogs don't have very good sweat glands, they use their salivatory glands to regulate their temperature, and they start panting so it can cool them off, which is very cool.
Cool.
So now you know why your dog is panting when you're taking it out for a run.
Awesome.
All right, let's see what you're doing over there, Katie.
All right, so guys, I have the water poured into the blender now, so I'm going to try to mash this up again. Let's see if we're able to digest this food a little bit more, because now in our mouth, we don't only have mechanical digestion, we also have chemical digestion with the water that is acting like our saliva. Wow. That worked way better. So I guess I was wrong. I guess the mouth doesn't just do mechanical digestion, but I also guess chemical digestion is very important for our mouth.
Wow, that worked really great. We have a question from one of our viewers. They said, ew, onions are yucky. So I think they agree with you, Katie. And they asked, why do onions make you cry?
You know what? Because I hate onions so much, I actually do have the answer to this. And it's because onions produce the chemical irritant known as synthroponethyl or S-oxide, and it stimulates the eye's lacrimal glands, so then you start to tear up. So essentially, onions contain a very kind of like icky little chemical that actually make your eyes tear up. So yes, we don't like onions, or I don't like onions, but I'm not crying just because I don't like them. It's actually part of the food.
Huh. Very interesting. All right, so speaking of food, let's get back to concentrating on where that donut is going. So we've went through the mouth. Now, where does it go from the mouth? Vanessa, can you help me out with this?
I absolutely can. So the muscles in our throat, they have a few different parts. The first part is called the pharynx. That's where it goes as soon as we swallow. You can actually feel, if you put your hand on your throat about here and you swallow, you can feel it moving around. So that's our pharynx moving. And then after it's in the pharynx, like we talked about a little bit earlier, that big word, the epiglottis, that is the area, the muscle flap that will tell our food or air where to go. So when you breathe in from your nose and your mouth, your air is going to go down, and then the epiglottis knows to send it to your lungs through your trachea. So it goes that way. If it messes up a little bit when you're eating, for example, your food is going to go into your lungs a little bit. That does not feel good, at least to me. I get a little burn in my chest. The food goes down the wrong pipe. But if the food does its job, then it will go into your esophagus. And the esophagus is the long tube that connects your mouth, or I guess from the epiglottis, down to your stomach. The epiglottis is very, very cool because it does this that little dance that I showed earlier where it kind of shakes and it moves. The muscles are getting tight and then they're opening again so that it can push your food down. That is called peristalsis. That is the technical term for how your esophagus gets your food down. And it does this pretty quickly because digestion itself, it takes a while. Our body wants to get all the nutrients it can, but it wants to get it to the stomach pretty fast. So it's only about 3 seconds to get the food from the past the epiglottis down to the stomach. It's pretty quick.
Wow, that's fast. Now, in an earlier episode, I think I recall another team member saying that they had a narrow esophagus. Katie, can you remind me who that was? Was it you?
That's right, Mackenzie. It was me. So, very interesting story is that I actually had a piece of steak stuck in my esophagus. If you wanted to hear the original time I kind of told that story, you'll have to go back to our previous episodes to watch that. But yeah, I got some steak stuck in my esophagus, and it was because my esophagus actually kind of narrowed. So, it's already a super small tube, but mine was even smaller in one component. So, it got stuck. We got to get the steak out, and then they actually widened it. So now it's back to normal, but it's very interesting how our human body works.
Whew, that's good news. I'm glad you got that figured out, Katie. All right, so in our demo, we went from the mouth, down the esophagus, into the stomach. So now that the donut is in the stomach, what happens when we get there?
So the stomach is also a very important part of our digestive system. And just like the mouth, it includes both mechanical and chemical digestion. So we are going to get into our activity now. So if you want to follow along at home, make sure you have your supplies. So we have our lemon juice, our Ziploc bag, and our crackers as well. Or if you wanted to grab a actual lemon and then grind up that lemon, then that would work as well, okay? So the first thing we are going to do is we are going to open up our crackers here, and we are going to take 2 or 3 crackers from this bag, and we are just going to kind of tear these crackers up with our hands.
So when you're crushing those up with your hands, is that mechanical digestion then, Katie?
Exactly, Mackenzie. So as I am crushing up these crackers, this is kind of acting as our teeth that are chewing up the food in our mouth. So you might want to do this inside of your plastic bag just so that it's a little bit less messy. But you should have something like this, 2, 3, 4, 5 crackers, however many you want. And then what we want to do is we want to take lemon juice. So lemon juice is not always found in our body, but for the purposes of our experiment, it is going to act as our stomach acid. So stomach acid is a super important component of our digestive system, and it really helps to start break down those food pieces better. So of course our body doesn't want to just take in these large chunks of food. It can't really do that. It needs to work at a very small level, and it needs to work with nutrients. So this is going to help our body break up these big food components into smaller bits that our body can actually use for energy. Okay, so what we want to do is we want to take our lemon juice or our lemon that's already pre-squeezed, and we want to add some into our Ziploc bag here. So you want to add quite a bit here. Make sure that you're covering up your crackers. Perfect. So once you have your lemon juice into your stomach, which is the stomach acid, I want you to go ahead and close that bag up again so that we're not making a big mess. And what we're going to do is we are going to churn just like the stomach does. So churning is the act of moving around the food, but now we have our stomach acid in. So if you take a look, you can actually see the crackers start to dissolve and kind of disintegrate. And that is exactly what happens when we are looking at stomach acid. So it actually works to completely dissolve the food in our stomach. And along with our churning, you can see that what started out as big crackers are now very small bits of liquid and food that our body is better able to use for digestion. So Mackenzie, I'm sure that this is what your donut looks like inside of your stomach right now.
It might be like donut soup by now, who knows?
Ew.
So we talked about stomach acid, but I think there's something else in our stomach that also helps us with digestion when it gets to that chamber. Vanessa, can you help us out with this?
Absolutely. So yes, our stomach is very acidic. We have it's there to just help break up our food, like Katie said, but sometimes if you're eating a lot of acidic food or just how it happens, it gets too acidic and then that can give you an upset tummy, and none of us really like that. So we have some vinegar here this time to represent our stomach acid, and these are pH testing strips. So our pH scale, it's a scale of 14, and the middle is 7. And if it's lower than 7, then it's acidic, like a lemon would be. And if it's higher than 7, then it's basic, like soap or things like that. So the way that the pH testing strips work are you rip it off, and then we're going to just put it into our vinegar to make sure we've got a baseline test. It's not going to be too crazy, too acidic, but it changes color a little bit, and it's looking to be, I'd say around a 4 is where it's kind of looking at right now. And then here we have some Tums, and Tums are some tablets that you can take if you're feeling not too great and it's acidic in your stomach. They are going to make your stomach a little bit more basic. So I'm going to just pour some of the Tums in there.
Now, Vanessa, I noticed you crushed those up. What is that? Why'd you crush those up? I was just curious.
Yeah, so I think our stomach, or when we're chewing them, they would get more chewed up by the teeth, like our mechanical digestion, and then it's gonna, it's going to get crushed up.
It makes it go faster, right?
Yes, exactly.
Yes. It increases the reaction rate. Very cool.
Yes, it's going to make it go faster, and so that we don't have to wait along for the whole Tums tablet to get crushed up. So yes, it's fizzing in here a little bit now, and we're going to test it again. Rip it off again, and dip it in, and then see if we get any nice color changes. I think the vinegar may have been sitting out a little bit, so it might not be super acidic like we want it to be, but hopefully it's got a little bit of a color change. Let's see. It looks a little bit too similar to what we want, making it more basic, so I'm going to add more of our Tums. Hopefully we can get more basic, but possibly the vinegar has been hanging out outside for too long. But it's fizzing because it's reacting, because they are opposite. One is really acidic and one is really basic. So we'll mix that up, see what happens.
All right, we'll just give that a second to dissolve. Now, it's really important that although Tums can help us, it's important that before you take anything like this, you ask your parents and guardians, because we want to make sure that we're taking them for the right reasons, and sometimes they're not always the answer. So although they can help us, we need to ask permission before we take them.
Definitely. So this seems pretty mixed up now. We'll give it a shot. Dip it in. It's looking pretty similar, unfortunately. It looks like it's sticking around the same pH of around 4.
All right, well, luckily, although our Tums didn't work perfectly, our stomach actually has a protective mucus lining in it that helps against this acid environment as well. Because stomach acid is really acidic, and it would hurt if it was just touching our stomach all the time. So there's this really thick protective mucus that surrounds our stomach, and it protects us so that it's not hurting our stomach or burning through. And actually, this mucus, it gets replaced approximately every 3 days, because the substances and mixtures and solutions that are in our stomach are constantly breaking it down. So it's constantly replacing it and making sure that's intact.
So I have a question for you, Mackenzie.
Okay.
My one friend had something called an ulcer. So I think that's something where the protective mucus actually kind of breaks down and it forms some open holes and like scars. Is that correct?
Yeah, that's right. So a stomach ulcer happens when part of the stomach lining, like the mucus, breaks down. So there's some things that we can get from our doctor, but luckily, because that mucus is constantly reproducing, it actually can sometimes fix itself. Otherwise, you can go see a doctor. So it's really important that we're eating the right foods and stuff so that we make sure that we can keep that environment nice and healthy in our stomach.
Cool.
Yeah. All right, so we've spent a lot of time in our stomach, but all of the digestion doesn't take place in our stomach. So next we need to go down to the small intestine. So I think we should take a trip there.
Perfect. So the small intestine is our next stop on our digestive system tract. And this is the part where we are going to do the second part of our main experiment. So for this, you're going to need some cotton balls, food coloring, a dish, some milk, and some dish soap as well. Okay.
All right. So while they're getting that ready, we just have a question from one of our viewers. So we have a question from Joe, and they asked, when I drink milk, my stomach sometimes gets upset. Why does that happen? Now, Vanessa, can you answer that question for us?
I absolutely can. So humans, when we're born, usually we're going to drink milk from our moms. Lots of other mammals also do this. So we need enzymes, which are little things that help our body move processes along, like digesting. So our enzymes, they can help us break things down, like the milk. The enzyme that does this is lactase. Typically, as humans get older, they would lose that enzyme. Sometimes people can keep it around because they're eating lots of dairy and cheese and milk from cows and stuff like that. So their lactase enzyme will stay around, but that it doesn't happen for everybody. So you're just lacking your lactase enzyme. It's missing, and it's not going to digest it properly. So the pieces that you're digesting are actually too big. So they go into your small intestine and large intestine just too big, and your body wants it to be very, very, very small, but they can't do it because you don't have your enzyme to help cut it up. Is there anything we can do about that?
Yeah, so sometimes people will take they'll take the enzyme in the form of a pill, and that will help just so that they can help digest it properly. Great, so that was a great question. If you have any more questions, just make sure you text us. Our number again is 306-570-1013. All right, so I think that everyone should have their materials now. So Katie, let's jump back into this experiment and see what happens in our small intestine.
Perfect. All right. So as we kind of stated before, the small intestine is a very important part of our digestive system because that is where a lot of digestion takes place. That is where a lot of our nutrients are taken in from the food that we eat. Okay. So this small intestine, it's a very large kind of tube, but that's not the only important part of this small intestine. We also need to have something called bile, which is secreted by the liver. Okay, so the liver, not many people know that that's actually part of the digestive system, but it is. So it's another organ that secretes this bile, and it secretes it into the small intestine, and it's stored in what's called the gallbladder, which is another organ. So bile, what is exactly its function? I thought that we could do this experiment today to see with our own eyes what this bile is going to do. Okay, so what we're going to do is we're going to take our bowl and we're going to take our milk. And what we want to do is we want to pour our milk right into that bowl, around a cup of milk. Perfect.
Looks like you're ready to have some cereal.
Oh, you know what? Cereal sounds fantastic right now. But because this is science, I will refrain from eating it and have cereal as my midnight snack tonight.
All right, sounds good.
All right.
Maybe
so
I'll have some tomorrow morning.
Oh, that sounds fantastic. All right, so now what we're going to do is we are going to take our food coloring. So whatever colors you have, they're going to work. We just kind of want a mixture of colors just because it's going to work a little bit better when we demonstrate this activity. So grab 3 or 4 different colors of food coloring. And what we're going to do is we are going to just kind of spurt 1 drop in each of the 4 quote-unquote corners of the milk. So we just kind of want it in a circle around the milk here.
Do you want the colors to be touching, Katie?
No, definitely not. We don't want these colors to touch. And once we demonstrate the activity, you will see why. But we want to make sure that they're very much spread out throughout your milk. Perfect. And then I'll add some yellow in here. And my milk will be set. All right. Perfect. All right. So right now we have our 3 or 4 food coloring little dots around our milk. And now what we're going to do is we are going to take our cotton ball. We're going to take our dish soap. And we're just going to put a little dab of the dish soap right onto the cotton ball. Okay, so it's on one side. Okay, so now what we're going to do is we are going to take this cotton ball, and we are going to stick it right into the center of the milk, right around in the middle of your 4 food coloring drops. Okay, so we want to make sure we are putting it right face down onto where the dish soap is. All right, so here we go. And now we're going to take a little bit of time as we see the food coloring is going to start swirling around. So this is going to take a couple of minutes. So if we wanted to get into some more questions and then come back and check on our food coloring, we could do that.
Yeah. So we have a great question here from the Hayes brothers. And they asked, why is the small intestine called the small, even if it is bigger than the large intestine? And that is actually because the lumen diameter is smaller than the diameter of the large intestine. So it's less wide. So the small intestine, although it is larger, the diameter is smaller than the large intestine. All right. We have another question here from a viewer. Haley said, whoa, Vanessa, you passed that Frisbee pretty well in the opening demo. Have you played Frisbee before?
I have played Frisbee before. One of my favorite sports is Ultimate Frisbee. So that's really awesome you picked up on that, Haley. I'm so glad.
Wow, very cool. Now, I have a question. So when I was younger, in the summer, I would always want to go swimming when it was still hot out right after supper. But my parents would always tell me that I can't go swimming for 30 minutes after I ate. Katie, do you know why that is? Why would they tell me that?
You know what? My parents told me the exact same thing. And if I was going to make a hypothesis, it would be that when we're swimming, we are physically moving our arms, we're really kind of thrashing around. And if we're doing that, then our food, if it's still in our stomach, kind of gets really tossed around. So if it does that repeatedly, then we might start to feel like a little bit sick. It's kind of the same thing if you were to go on a run or something after. So any kind of physical activity, we want to wait around that half an hour mark just to make sure our food is starting to digest, a little bit more is out of that stomach so it's not completely tossing and turning. So if we want to check back on our experiment now, you can see here that I have swirls in my milk. We're just going to get a close-up. Perfect. So you can kind of see that I have some swirls where my food coloring is, and they're not really in perfect little dots anymore. Okay, so this is demonstrating what is happening when the bile reaches our small intestine. So a little bit of background knowledge here is that there are 3 kind of main macronutrients which are found in our foods. So we have carbs, so that's kind of sugars, that's like breads, pasta, rice. We also have protein, which is our meat, our eggs, our soybeans. And then we also have fats, which is an example of a healthy fat would be found in avocados. So the fat takes a little bit more breaking down than the protein and the carbs. And so this is what the function of bile is. It helps to break down fat into smaller components so that our body can properly use this fat. So in this demonstration, the dish soap is acting as that bile. So what happens is when we put that dish soap on the cotton ball and put it into our milk, the dish soap starts to break down that fat in that milk, which is exactly what the bile does in the food in our small intestine. It starts to break down that fat, and in our activity, as the fat is broken down, it starts to swirl that milk around, which then swirls the food coloring around, and it creates kind of a pretty picture. So I hope it works for you guys at home. If it did, feel free to text us in those pictures.
Yeah. So another thing that happens in the small intestine, as Katie was saying, is all of these things get broken down and we start to take up a lot of different nutrients. Now, one thing that the small intestine has that helps with this is something called villi. So these are finger-like projections and they help increase the surface area. To understand this more, we're going to put our hand in a fist. So when our hand is in a fist, we have air touching us all around here. But if we add something like villi and we spread our hands, we have all of these finger-like projections, we have all of the air touching us all around on our fingers, and this helps to increase the surface area. So that means that the solution and all of the food and nutrients are able to touch us in more places, and it's able to get absorbed even more. So it just helps to make sure we're doing things at maximum efficiency and keep us healthy. All right. So we've done a lot of the digestion in our small intestine, but now we need to go down to the large intestine.
Perfect. Yes, our large intestine comes right after our small one, and it's made up of 3 big parts. So we have first our descending colon, and then our transverse colon, and then our ascending colon. So our descending colon and transverse colon do very similar jobs. Lots of it is just to get the water out of there because, like we were mentioning earlier, the small intestine, it takes a lot of the nutrients and important things right out for our body to use and leaves the rest of it. And lots of the stuff that's left is water. But our body wants to hold on to the water. We need it for so many things. So we're going to keep it. And that is a big job of our descending colon and transverse colon. It then will go into our ascending colon, and then it gets stored there until it's ready to move on for us to get rid of it. So yes, one thing that's really important for us to do is to keep our colons super happy, because not only are we living there, but there's also some little bacteria that we're going to talk about later, and they need to stay happy as well, along with our colon. One really great way to do this is to eat a lot of fiber. So fiber is really important for us, but it's kind of, who knows what's in fiber? It's like, it could be in anything. Some great foods that it's always going to be in are apples and pears, especially the peel. It's in beans. Some cereals are really great. Usually they tell you if it's a high fiber cereal, and whole grain bread, wraps, stuff like that. Those are all going to keep your colon and all the bacteria in there super happy so that it can keep doing its job, getting the rest of the nutrients that are left and all of the water.
All right. So earlier I was saying how a lot of the nutrients get taken up in the small intestine. So when it gets to the large intestine, there's a lot of water and liquid that's left. So what does that have to do, and what happens in the large intestine with all of this liquid, Vanessa?
Yes, so we're going to use a towel to demonstrate that. So I'm going to unravel it, and then I'm just going to oh wait, before we do that, I think maybe we should show what might happen in the small intestine. So I have a little bit of paper towel here, and obviously this is thicker, it's bigger, and our large intestine is actually 5 feet long. So it's very long, and it's almost as tall as I am and Mackenzie and Katie are.
Wow, it must be squished up really good.
It is, it really is. It condenses super well to actually fit and everything like that. But if we're going to show our small intestine, because it's smaller, it's not so big, I made it about this big, just kind of rolled it up, and then I'm just going to dip it in the water. And maybe wring it out a little bit, see how much water we could really hold. So I'm kind of trying to twist it. It's not super great. So that's kind of why we don't really want to do it in our small intestine. So that's what our large intestine is for. It's way bigger, and it's going to be really a lot more absorbent. So I'm going to try and just dip the end, or this kind of squished up part, in to the water, see how much we can soak up, and then take it out. Oh my goodness, it's already even heavier. So I'm going to try and wring that out, try not to make a mess. And look at that, it holds way more water. So that helps our body just take it up. And all of this water that I'm squeezing out, it would be in our body, going to all of the important parts that need it, helping us make saliva, all of that kind of stuff.
All right. Perfect. So I think I understand now. So I'm just going to do a quick demonstration, and then Katie and Vanessa, you're my scientists, so you'll correct me if I'm wrong, right?
Sounds
Exactly.
good.
Okay. So I have this solution here. I'm going to get rid of my donut. You see this? So I have my solution here. It's got some berries in it and all of that great stuff. So I'm going to use this strainer to act like my small intestine. And here's my solution. It's like my food and my saliva. So if this is like my small intestine, it's kind of catching a lot of the big chunks and the berries. So these are like the nutrients, and then all of the water gets passed through into the large intestine, and that's where it'll be taken up. But I noticed that there is it looks like it turned into juice rather than just water. So those nutrients that got moved into the large intestine, who uses those nutrients?
Yes, that is our gut bacteria. And the gut bacteria, there's lots. I've heard there's even like millions of bacteria that just live in our gut to help us continue breaking down our food. So our food's able to go in there, and then it's stuff that we can't really use. Our body doesn't need it, or we need it, but we can't help break it down. So the gut bacteria do that extra step for us and then give it back to us.
Wow, that is very important. I didn't know we had all of that going on. All right, so it sounds like there's a lot going on and that it's really important that we're making sure we put the right stuff into our body to keep not only us happy, but all of the bacteria that's in there as well.
Exactly. So, because our digestive system is so important, we are going to be looking at our STEM spotlight today, which is a dietitian right here in Regina, and her name is Jenna Kress. So, I think we have an image here. We're going to put up her biography here up on the screen, and we're just going to talk a little bit more about Jenna. So Jenna went to Saskatoon to train to become a dietitian. And dietitians are a very important role in our healthcare system that help to ensure we are eating the right foods for whatever our body needs. So for example, if there's like an athlete who's training for a big event that needs a certain diet, dietitians can help there. Or perhaps if somebody is sick in the hospital and they need a special diet, dietitians can help there. So they're a very diverse group of healthcare professionals. And Jenna works at a clinic right here in Regina. And she likes to specifically focus on looking at foods that can help to make us healthier, as well as prevent inflammation, which is the swelling of our digestive system that might not make us feel that great. So along with that, Jenna also works as a motivator for the Wheelhouse Club here at Regina, and she's also into makeup as well. And so she's really helping our healthcare professional team out here. So thank you, Jenna, for all of your work.
Wow. So basically, I understood that healthy food equals a healthy gut, which equals healthy digestion. So it's really important that we're putting all of these great things into our body, which is why our parents and guardians tell us that we should be eating healthy foods or fruits and vegetables so that everything works as good as it can. Now, we talked about having bacteria in our gut, and bacteria is sometimes really good. In fact, 99% of bacteria is good bacteria, and we actually need it. Without this bacteria, our digestive system wouldn't work as well as it needs to. This interaction is called a symbiosis. So a symbiosis is when two living things interact together. Now, a symbiosis, just by hearing that word, we don't know if it's a good relationship or a bad relationship or if they're helping each other out. So we want to know if these bacteria in our stomach are helping us or not. So Katie, I see you have something on your desk there. What is that?
Well, guys, one of my absolute favorite foods in the world is mini eggs, and I decided to bring some leftover mini eggs for a snack this afternoon. But I do kind of have a bit of a confession. I do very much enjoy cookies and cream chocolate, way better than milk chocolate. So I'm going to put up with these, but they're really not my favorite.
So I think you're looking to trade it. So you're looking for something that is going to give you something and you'll give them something. So that's kind of what's happening in our stomach as well, and our gut with these bacteria. We want to make sure that they're giving and taking equally so that it's beneficial to both of us. So Katie, why don't you see if somebody around this studio has something to trade with you?
You know what? That's perfect. I definitely saw a cookies and cream chocolate before the show, and I think it belonged to my friend Fiona.
Yeah, let's see. Fiona, can you come out here?
Well, hello everyone. You know, my name is Fiona, and my favorite chocolate is milk chocolate.
Milk chocolate?
And I have here a cookies and cream bunny, and honestly, I don't really like it that much.
Well, you know what, Fiona? That would be amazing if I could trade this with you.
Really now?
Yes.
Well, I think that would be a really good idea if we could trade my cookies and cream bunny for those amazing milk chocolate.
Yes, I agree. And I think that's a fair trade because before the show, Vanessa was trying to make a trade with me. She was trying to steal my mini eggs, but she had nothing to offer me. So that is not the type of relationship we want with our gut bacteria. We want the type of relationship that they give a little, we give a little, they take a little, and we take a little as well. So here, we're going to use these fancy dancy social distancing claws to make our trade. All right, so I'm going to pass this off here to Mackenzie.
All right, here we go. We're going to make this beneficial trade to both of you here. Oh, here we go.
Oh,
good.
Thank you.
Now you have to give her something back in return. So I'll take your cookies and cream here,
Oh, there you are.
and we'll give that over. Now I'm just gonna check in with both of you. Fiona, are you happy with the trade?
I am very happy with the trade.
All right, and Katie, are you happy with the trade?
Oh, I am very, very happy with the trade, and it looks like Skylar is pretty happy with the trade as well.
Skylar got excited by the food.
I bet Skylar is salivating.
He must be.
I betcha. Yes.
I think so.
All right, so this trade, it benefited Katie and Fiona. So does anyone know what word describes that symbiosis?
Well, Mackenzie, I do believe that this type of symbiosis is mutualism. And that means that we both get something that we trade that we both like in the end.
Wow, that's great. Well, that's what's happening with lots of the bacteria in our gut too. So we need to make sure that because they're helping us with our digestion, we need to make sure that we're helping them too by giving them the right foods and nutrients that they need too, so we can keep this relationship going strong.
So maybe I shouldn't eat this entire chocolate bunny all at once?
Maybe it's not the best idea. Maybe eat it in small chunks. Now, thanks for joining us, Fiona. Do you think you want to come back?
I would absolutely love to come back. Science is so much fun.
I agree. Well, we'd love to have you back on the show. So I hope you can make it tomorrow, and then you'll join us here at the Couch Potato Lab.
Oh, I'll be there.
Awesome.
Bye,
Great.
Fiona.
Bye, Fiona.
Bye, Fiona. Oh, we've went through the mouth. We've went through the stomach, esophagus, small and large intestine. And do we have anywhere else to go?
You know what? That's basically it. Once that food is secreted out, then we're good to go.
Not our problem anymore. It's all
Yeah.
gone.
All right, cool. So we have a question here from one of our viewers, and they asked, are all digestion systems the same? Now, Katie, is that true? Is like the animals, let's compare us to cows. Do we have the exact same digestion system?
No, we actually do not. So, humans have one stomach, for example. We do not have multiple stomachs, doesn't really work like that. But cows actually have a few stomachs. So, they are known as polygastric, and we are known as monogastric. So, not all the animals have the exact same digestive system as us. We are kind of a linear line, and they kind of have multiple routes to go.
Yeah, all right. So we're going to continue on with our Ask a Scientist segment. So we have a few more questions here. Of course, you can text us in as well. So we have a question from our viewer, Georgie, and they want to know, why do people burp and fart? Okay.
Interesting question.
Well, so what happens when we're burping is that the extra gas in our upper digestive tract, it comes up through our esophagus and it escapes through our mouth. So it's kind of taking like the shortest route possible, and it comes up in the form of a burp. Pretty interesting.
A fart is also kind of interesting. It can even come from the bacteria that we were talking about earlier, because we give it food and then it will make something for itself, but it also has to release something, and that's usually going to be a little bit of gas, and then all the gut bacteria all together will make all the gas together, and then that comes out of our lower digestive tract.
All right. So we have another question from Georgie. They asked, one of my friends has diabetes. She said that she can't eat a lot of sugary foods like donuts or baked goods. that I make for her. Why is that? Katie, can you answer that for us?
Yes, I definitely can. So quite a few people I know are also diabetic. So what's happening there is that our body produces something called insulin, and insulin helps to regulate body's glucose or sugar levels. So sugar, remember we talked about carbs, that's kind of where it comes from. So it's very important that the sugar levels in our body are intact and in balance. So what happens is when somebody is diabetic, their body does not produce enough insulin or it doesn't work properly. So the insulin that they produce, it doesn't work to help regulate the body's glucose as well as somebody who is not diabetic and who has insulin that is working in enough amounts or is working properly. So your friend cannot have as much as those sweet goodies and stuff because if he or she eats a lot of that sugar, then their body cannot properly use that sugar in a balanced way. So it's very important for people who are diabetic to maintain a healthy diet and eat a proper amount of sugar that is not too much but not too little either.
All right. Now, Vanessa, we have a question from you. We have a question from Gazelle, and they're wondering, my mom says that eating carrots are good for your eyes. Why is that?
That's a really, really great question because I've heard that a lot too. Carrots have this really important vitamin called vitamin A. That's a nutrient for good vision. It helps your eyes keep you seeing really well. Eating carrots it only provides a little bit of vitamin A though. So that's where the myth comes from. Well, not myth, but the idea that carrots help you. We can also get vitamin A from a lot of other sources though, not only the food that rabbits like. We can get it from milk, cheese, egg yolks, and liver. So vitamin A is very, very important.
All right. And we have another question. Catherine is wondering, how do vegetarians get protein if they don't eat meat?
All right, so vegetarians actually have a lot of options to get their protein. And of course, meat is a very important protein, but just because somebody is a vegetarian or vegan does not mean that they're not getting enough protein. There's a lot of other foods that contain the protein that they need. So for example, peanuts and nuts often have a lot of protein that will help there. There's soybeans, different legumes, eggs. So there's a lot of different options that are not meat that vegetarians can also get that protein. And just like with carbs and fats, it is also very important to have that proper balance of protein for our body to function properly.
Yeah, we had a great time. Thank you for teaching me what happens with my donut. I can't wait to continue eating it after the show on my coffee break and know exactly what is happening and where it's going. That's everything we have for you today.